Hello everyone, welcome to this session on deep learning interview questions. Today in this session, we will be discussing the top interview questions that can be asked to you when you apply for a deep learning role. So let's get started. But before we move on guys, if you haven't already, please subscribe to the Intellipaat channel and also click on that bell icon to never miss out on any updates from us. So now let's move on and start off with the agenda. So guys, first we'll discuss some questions about model fitting and then move on to discuss some questions over deep learning frameworks. Once we're done with that, we'll move on and talk about data propagation, and then we'll move on and to talk about hyperparameters usage. Once we're done with that, we'll move on and talk about neural network usage, and then some questions about various deep learning algorithms. Finally, we'll be taking up some complex scenarios around deep learning and putting down some questions which can be asked to you in your next interview. So guys, this is the agenda for this video. I hope it's clear to you. Now let's move on and start off with our first topic.
Coming to the first question on these top deep learning interview questions set, the first question is, what are the differences between machine learning and deep learning? This is a very common question that's asked, and it is very important that you know the basic differences that lie between machine learning and deep learning. One very good commonality is that both of these are actually subsets of artificial intelligence, and deep learning itself is actually a part of machine learning. So when we talk about machine learning, we're making sure that we find a way where we're training machines with a lot of data. We give it some data and we hide some data from it, in fact. And we use the hidden data later, which we also call as the testing data, to make sure that the machine learns something, and to verify if it has actually learned from its experience. When it comes to deep learning, we try to find methodologies and ways where we can sort of trick the machine into making it think like a human being, making it use the human brain structure in terms of working. In the concepts of neural networks, the entire concept is named after neurons and the use of neurons as well, just because how very similar to how it works in the human brain. So this forms to be the basic difference between machine learning and deep learning. Moving on to the second question, it says, what is perceptron? Perceptron is a very important concept in deep learning because it actually matches what we see in an actual neuron in a human brain. So coming to how it works in deep learning, a perceptron actually receives inputs from a variety of entities, and then later it takes these entities, applies some transformations on it, what we call as functions. It applies functions on this, and then it becomes the output. So input, perceptron, applying function, output. That is how the order goes. So if you have to talk about when perceptron is mainly used, it is actually used when we go on to perform binary classification, where we use an input, we try to see if we can classify something based on the output. There's so many factors when we talk about the functions as well. There is weights, there is biases, and there's a lot of things in a neural network in deep learning that has a lot of impact. And in this system itself, perceptrons play a very important role to take an input and transform it and work on it to give you a valid output in the case of classifiers as well. Now coming to question number 3, it states, how is deep learning better than machine learning? Both deep learning and machine learning are very powerful in their own ways. To solve most of the complex problem in a very simple way, machine learning has got it covered. But then when you talk about deep learning will overpower machine learning, especially when it comes to working with data that has huge number of dimensions. Think about an Excel sheet which has about, let's say, 100 columns with 35,000 entries each, something like that. So when there's a lot of data in your data set and the dimensions are very large, deep learning will be exponentially efficient at working with things than compared to machine learning. So if your data is large, then a deep learning model will work very efficiently to actually solve it, handle it, and it'll make it easier for you to program and work with it at the same time as well. So this is how deep learning is having the upper hand over machine learning in a very simple and a concise way. Now moving on to the fourth question, it states, what are some of the most used applications of deep learning? Again, this is a very common question that can be asked in your deep learning interviews. So at least make sure you mention at least 3 or 4 fields, and in fact I've put up around 6 fields on the screen right now. Everything from sentiment analysis, mostly Twitter, and all of that. Then we have computer vision to analyze graphics. Then we have automatic text generation, we have object detection, we have NLP, natural language processing, and image recognition. There are more fields. You can name about 10 to 12 offhand if you have worked a little bit on deep learning, but then it doesn't make it doesn't really add a lot of value if you just list 10 to 12. So rather, just tell 5 or 6, and just explain 1 or 2 lines about what each of them mean. That way the interviewer has an idea that you are concrete with respect to all the concepts there as well. Now with this, we can come to question number 5, that states, what is the meaning of overfitting? Overfitting and underfitting are actually two very common issues that have to be dealt with whenever you're working with data sets and whenever you're working with deep learning. Overfitting, as the name suggests, is a scenario where you have a deep learning algorithm, and your deep learning algorithm is looking very hard into your data, and it is trying to hunt for meaning. It is trying to find some meaningful correlations in between the data in the data set. Now, in a way, what happens in overfitting is that it will start vigorously hunting for the data, and this makes it pick up noise, what we call as noise, rather than any sort of useful data. So with this noise, it hurts the efficiency, it hurts the detection capacity of the model. So rather than picking up any useful valid information, your model will start picking up noise, and that is not a good thing. So what happens is, at the end of the day, you'll have a very high variance in your data and a very low bias. This way, of course, you would already know that your model will be very, very inaccurate in terms of detection, and very inefficient at detecting new things, even if it has a good level of accuracy as well. So when you think about it, overfitting needs to be fixed, and underfitting is just the reverse of this. Anyway, coming on to the 6th question, it says, what are activation functions? Activation functions are very important entities in deep learning, because these are the actual functions that will take your input and make sure that you have something usable on it. So the transformations that happen, right, it is all because of the activation function. So what an activation function is basically is that it has the capability to decide if a neuron actually needs activation or not in that particular array, in that particular set of neurons, to see if there has to be anything modeled from that particular neuron in the chain in the neural network, or if it adds a value to the next set of neurons as well. So this is actually done by calculating the weighted sum of it and then taking the bias as well. So at the end of the day, whenever you're making use of an activation function, the model output will be non-linear. And if you have to talk about the types of activation functions as well, so there's rectified linear unit, or ReLu for short. You have softmax, sigmoid, linear, tanh, and many others as well. So it adds value that you answer it in a way where you tell what activation functions are, how they're calculated, what the output will look like, and what are the types of activation functions as well. With this, we come to the 7th question that states, what is Fourier transforms that is used in deep learning? Fourier transform is very vital to deep learning, because it is one of these packages that is used to manage and work with a lot of data when we work with deep learning. As you already know, in deep learning we will be working with huge data sets, so we need methods and tools and techniques where we can process these in real time, and we can make sure that we can handle it and work with it easily and quickly as well. So Fourier transforms is one of these packages that will make sure that you have high efficiency whenever you're working with data. And with Fourier transforms, your model is now open to a lot of signals where you can have the data processed from multiple entities, and to just make sure that you're opening up a dimension when you're working with the data as well. So Fourier transforms are a very vital part of deep learning. Now with this, we can come to question number 8 that states, what are the steps involved in training a perceptron in deep learning? There are about 5 to 6 steps whenever we have to talk about the perceptron learning, or training a perceptron as it's also called as, and these are the 5 steps. Firstly, the first step is always to initialize all the thresholds and the weights of the network. Then of course we'll be providing the actual inputs. The outputs are calculated based on a lot of things, and we have back propagation, all the algorithms that run in the back end, and after which we'll have the steps where we'll be upgrading the weights in every single step. So after the weights are upgraded, calculated, then we'll again provide another set of inputs. We'll be calculating the weights again, and this goes on from the starting initial node all the way till the last node of the output neural network. And this is how simple it is to actually train a perceptron in deep learning. Now with this, we can move on to the ninth question that states, what is the use of the loss function? So, whenever we talk about neural networks and deep learning, we need a methodology, we need a number, we need a numeric where we have the ability to see if the model is working towards its goal or not, right? So the loss function is a measure of accuracy here as well, because we're trying to see if the neural network actually learned something useful from the data or not. And a loss function is a negative metric where if the loss function's value is less, then it's good for the model. If the loss function value is high, it means that the model is not performing well. So at all times, it is very vital that you mention that the loss function has to be kept to a minimal extent. Now with this, we can come to the 10th question that states, what are some of the deep learning frameworks or tools that you have used in the past? Now this is a very common question that's asked in the interviews because they want to find out, the interviewers want to find out about the experience that you have with all of these tools. So just make sure to mention of all the frameworks, tools and techniques that you might have used in your projects or your certification programs, or whatever it is that you have used, the methodologies that you have used to learn. Of course, there are many top deep learning frameworks out there. We have an entire video on that on the channel as well, so make sure to check that out after this video. Among the top deep learning frameworks, we have TensorFlow, we have Keras, we have PyTorch, we have Cafe2, we have CNTK, that's Microsoft's cognitive toolkit. Then we have MXNet, we have Theanon, we have many others. In fact, you can list about 12 to 15 very good top deep learning frameworks out there. But then just make sure to mention 3 or 4. But then if you of course used more than that, then do make sure you mention that as well. But then make sure that you are very honest about it, and do not I would suggest that you do not state a deep learning framework that you might have not used, as that might lead to you being asked questions on that, and you not being able to answer as well. So make sure to take care about that. Now with this, we can come to the 11th question that states, what is the use of the swish function? So the swish function is nothing but an activation function, as we discussed a while ago. So it's something called as a self-gated activation function, and it is developed by the people at Google. So one thing to note about the swish function is that it is extremely popular because Google has put up a very good claim that it outperforms all of the other activation functions that exists today in terms of efficiency. So we discussed the different types of activation functions as well, right? Tanich, ReLu, and all of these. So then Google came about, they devised an algorithm, the activation function algorithm, and they put up saying that this will outperform everything else that already exists. So that is one of the reasons why this particular activation function has seen so much limelight as well. Now with this, we can come to the 12th question that states, what are autoencoders? Autoencoders itself are artificial neural networks, and this is something which is very important that you know. And of course, they do not have any supervision, as they have the ability to automatically try and map inputs and to find out outputs and work with it on their own. So it's a very interesting concept to work with autoencoders, and these are very efficient as well. But then when we talk about autoencoders, it is very vital that we talk about two important things. One is the encoder and one is the decoder. These two are the very important entities that we have to discuss about. An encoder will make sure that the input is taken and it is converted into a format which is understood by the neural network into an internal computation state, of course. And then we have the decoder, which does the exact opposite of this. It will take the computational state data and it will make sure to convert it back into the output. So encoders, even though the name only has encoders, there are two operations that's going on. One is the encoder operation and the other one is the decoder operation. Now with this, we can check out the 13th question that states, what are the steps that have to be taken whenever you make use of a gradient descent algorithm? There are actually 5 to 6 steps that have to be discussed whenever we talk about initializing and making use of the gradient descent algorithm. The first step is always, you have to initialize all the biases and weights for the network as well. And after you have initialized all the biases, you have to send the input data throughout the network, which forms to be, of course, the input layer, the first layer of your neural network. And then we'll actually calculate the loss function, right? So you'll have an expected value that you're expecting at that point of time, and there will be a value which is predicted by the model as well. So calculating the difference between this will give you the error of how far away the neural network is from the actual goal. Now, after that, you will actually change all the values in the neurons to make sure to find ways where you can minimize this loss function, this difference that we just found out in step 3. And after which, of course, this entire process is an iterative process. You'll be looping it and doing across multiple iterations to find out what biases, what weights, and how best you can do to keep the loss function at its minimum. So these are some of the steps that have to be followed whenever you're working with gradient descent algorithm as well. So with this, we can come to the 14th question that states differentiate between a single layer perceptron and a multi-layer perceptron. We already discussed that if we're talking about a perceptron, in case if it's a single layer perceptron, it will not have the ability to classify non-linear data for us, but then a multi-layer perceptron completely can classify non-linear data. And a single layer perceptron is a bit limited in one aspect where the number of parameter that it takes in is very less when you compare to a multi-layer perceptron, and this in big deep learning models can have a very disastrous effect as well for efficiency, for effective working and whatnot. So again, for the second point, I think multi-layer perceptron wins. And when you talk about the third difference, of course, a single layer perceptron has many things that it can do well. But if we are talking about efficiency when making use of large data, again, a multi-layer perceptron of course takes the higher end because it is extremely efficient to work with in the case of large data sets. Now with this, we can come to the next question that states, what is data normalization in deep learning? So data normalization is a very important step. It is actually a pre-processing step where we try to make sure we can move around the data, rearrange the data, and we can make sure to refit and pack this data into one particular range. This is the entire process of normalization. Why we do this is to make sure that if your data is in one particular range, it means that your network has the ability to learn very effectively and be very efficient as well. So when you're performing steps like backpropagation, having a data in a very structured range, a specific range, will make sure that your network can learn that much faster as well. So these are one or two reasons why this pre-processing step that we take called as data normalization is very important. Now with this, we can come to the 16th question that states, what is forward propagation? So backward propagation is the scenario where we work from the output layer to the input layer, and here in forward propagation it is the exact reverse. We follow in the order of the neural network. So we go from the input layers to the hidden layers and then the output layer. So when you're talking about a complex neural network, there'll be more than one hidden layer. So for every hidden layer, the output of the activation function is actually calculated, and this is done until the next layer can actually be processed. The reason they call it forward propagation, as I just mentioned, is to make sure we work from the input and towards the output, and this is the exact opposite of the backward propagation algorithm as well. So to make sure that we use the output of the activation function and to calculate it for the next layers, forward propagation is very important. Now with this, we can check out the 17th question. Again, coming back to the very main important question, your interview could start with this question itself. What is backpropagation? So backpropagation, instead of talking about what, the first thing you have to always discuss is why backpropagation is even important, right? So it is to make sure that we keep the loss function or the cost function less, and to see how the values changes whenever we, work with a variety of biases, a variety of weights. Whenever we change all of these, even a slight change can have a very big impact on your model. To understand how these work, we require the backpropagation. It's called backpropagation, of course, because it starts from the output layer, works backwards towards the input layer direction. So how is backpropagation calculated? Well, it is very easily calculated whenever you work by understanding the gradient that is calculated at every single hidden layer itself. So it's as easy and straightforward as that. Now with this, we can check out the 18th question that states, what are hyperparameters in deep learning? So when you talk about hyperparameters, even though the term is very complex, they're nothing but variables that are actually used in deep learning to actually determine the structure of a neural network. So these variables are put into place to make sure that we have an easy way of understanding so many different factors and parameters in the deep learning model, be it the number of hidden layers that are present, or the learning rate of the model, and much more. So hyperparameters are very important variables that will give us a lot of insight into how the model or the neural network is functioning as well. So moving on to the next question, it states, how can hyperparameters be trained in neural networks? So training a hyperparameter is very important, and understanding how you can convey this to the interviewer is also very important, because these are long procedures and your ability to concisely answer it is very important. So, to train a hyperparameter, we'll require four very important components. It's the batch size, the number of epochs, and there's something called as the momentum, and there's a metric called as the learning rate. So what happens in batch size is that we'll take the input, we'll split it into batches. Batch size can be varied depending on however it is required based on the efficiency and a lot of other things. These batches can be cut into further sub batches as well, if that is the requirement. So instead of pushing all the input into a concurrent pipeline, we just make sure to dig it up into batches and then vary it across. Now, when you talk about epoch, an epoch is basically a denotion of how many times the training data is run through the neural networks where it can train. So the number of epochs is the number of iterations at which the neural network trains as well. So it's an iterative process. The number will depend on so many different factors. Doesn't mean that if you have a large number of epochs that your model will be very, very accurate with every single iteration. It will go up to a point, and then of course your model will work in fact in the opposite direction. Now, when you talk about momentum is actually put into place where we have an idea to check out what happens in the next consecutive steps. Whenever data is being moved around in a neural network, it is vital to understand what happens next, right? So, there is no point if your model is very inefficient where it's passing around data and not driving any momentum from it. So momentum is this particular track where we make sure we understand what's happening next as well. Now, coming to the last component, it's a very important component. It's the learning rate. Learning rate is what we are all after when you work with deep learning, because this is used as a very important parameter where we're trying to denote what is the time that's required to actually update all the parameters when your model learns and when your neural network is ready to take in certain inputs and give you meaningful outputs as well. So these, four form to be very, very vital, very important components in the world of deep learning whenever we go on to train hyperparameters. Now with this we can come to the 20th question that states, what is the meaning of a dropout in deep learning? Now, dropout might seem like a very common term, but it is actually a technique in the world of deep learning. Dropouts are a very important technique, in fact, because these are used to avoid overfitting. Overfitting and underfitting are common problems as we discussed a couple of questions ago. So to avoid overfitting, to make sure that your model doesn't hunt for noise, what we actually do is, we purposefully remove a bit of data which might not be useful for the model to learn as well. So if you have a dropout value to be very low, it will have a minimal effect on learning because you're not removing enough data and your model can still go towards overfitting. But then if you remove a lot of data, then what will happen is the model will not have enough data to learn. So it will underlearn and then cause inefficiency as well. So this value, right, this drop off value should be very, very vital, because if you have it too low, it will not have an impact. If you have it too high, then your model will not learn effectively anymore. So understanding this is a key concept. Now, coming on to the 21st question, it states, what are tensors? Tensors, you might have heard of these. These are another name of arrays, guys. So tensors are actually multi-dimensional arrays that are mostly used in deep learning, where we have to represent data across either one dimension or in fact multiple dimensions as well. So why can't we just call them arrays and not tensors, right? So tensors have the specialty of a name because they have been very famous. They have been very vital whenever we work with data of higher dimensions. So one very big advantage when we talk about tensors is that whenever we make use of it in any of the programming languages, right, the syntax is very readable. It's a very high level syntax. So what that does is it gives us a clear picture of tensors, even though if we do not have very high amount of training in terms of making use of tensors or its terminology. As soon as we look at the programs, we'll have a keen idea about what tensors are and what they might be doing in the program as well. So this is one very good advantage when it comes to working with these multidimensional arrays called as tensors. Now we can move on to the 22nd question that states, what is the meaning of model capacity in deep learning? Model capacity is again a very important metric that we have to discuss about, because model capacity deals with the capacity of the model to actually take in a variety of mapping functions. So how many mapping functions can your model handle? How many can it concurrently work with as well? One thing we drive out of this metric is that higher the model capacity, it literally means that there is a large amount of information that can be stored and worked with in the network. If the model capacity is low, as the name name suggests, it means it cannot handle an effectively a large amount of information at a time as well. So model capacity is something which is very straightforward, but yet it forms to be a very important concept in deep learning. Now with this we can come to the 23rd question that states, what is the Boltzmann machine? Boltzmann machine sounds very complex, but it is actually a type of a neural network, that we call as an RNN, or a recurrent neural network, where we make use of binary decisions, biases, and to do a lot of functioning and working for us as well. So Boltzmann machines are, like as I mentioned, RNNs. They are hooked together to create something that we call as DBNs, or deep belief networks. So these deep belief networks are extremely sophisticated. They have multiple number of hidden layers, and they're put into place because we have complex problems that require effective solving. So the entire goal of deep learning, in fact, is that we have extremely complicated problems, and we need to find ways to make use of the power of computing to simplify that to a good extent for us, and a Boltzmann machine will do exactly that. Now, after understanding this, we need to check out what are the advantages of making use of one of the top deep learning frameworks out there called TensorFlow. So, of course, this could be a very important question in case if you work with TensorFlow, because understanding the advantages of it is very vital. So TensorFlow has many advantages, and to me the most important advantage is where it will give you a lot of flexibility and platform independence whenever you're working with it. The platform independence is very vital because we all have multiple operating systems, multiple platforms that we work on, and of course, so it has the ability to power through and train on both CPU and your graphical processing unit as well. And with new technologies with GPUs, it just makes it very efficient to work with tensors too. And then when we talk about auto differentiation and the features it brings with it, is again a huge impact. When we talk about threads and its ability to handle asynchronous computation, this is where TensorFlow wins over many other deep learning frameworks as well. The second most important advantage to me is that it's open source. It has a beautifully large community, so you don't have to pay for it, but then at the end of the day, there are so many things that are being added in terms of features, technologies, fixes, and so much more. And this entire community of open source is just a beautiful thing, and I'm sure you can relate to this if you work with TensorFlow as well. So with this, we come to the 25th question that states, what is a computational graph in deep learning? So a computational graph, as the name suggests, is a scenario, or is a graph itself, where we try to take inputs, arrange them into meaningful entities called as nodes, and later create a graph structure out of it. So these are done to simplify certain mathematical calculations and to visualize them better. So in terms of deep learning and in terms of backend functionality, it helps a lot whenever we're working with parallel processing, as it provides a huge performance boost over a single threaded performance in terms of making use of actual computational graphs, as your processing power is now 2, 3, 4, 5 or 10 times, 10 folds better than how it was before as well. So computational graphs are very important units when it comes to working with deep learning. Now, we can come to the 26th question that states, what are CNNs? CNNs and RNNs are very different types of neural networks. A CNN stands for convolutional neural network, while an RNN stands for recurrent neural networks. Now, coming to the talk of CNNs are mostly used to perform visual analysis, or working with a lot of images and classification as well. You can have multiple images of many channels as well. So when we talk about images and channels, mostly we talk about colored images and black and white images. Colored images will have like 3 channels, red, green and blue, RGB structure, and so much more as well, right? So a CNN has the ability to easily work with, classify, and give you meaningful outputs on all of these images and visual data. Now, if we talk about a little bit more about CNNs, the next question can be saying, what are the various layers that are present in a convolutional neural network? So when the talk is of this, understand that there are 4 important layers in a convolutional neural network. One is the convolution layer, we have the ReLu layer, or the activation function layer as it's also called. Then we have the pooling layer and the connectedness layer. So when we talk about the convolutional layer, this is where we apply things and entities called as filters across the main data to have them as parameters to teach and train the network. So after the convolution step is done, we'll use the activation function to squish it and bring it into a range range which is workable and understandable by the neural network. After the activation function is done, then there's something called as pooling. Pooling is where again we shrink the data to make sure we are not losing any of the existing data, and what happens after convolution is we lose certain data as well. So we do stuffing in the pooling layer as well to make sure that we add certain bits, dummy bits, to make sure that the size of the image is actually maintained after every single iteration. So with every iteration the image shrinks a little, and with padding we make sure that we are not letting it shrink out of context as well. And then when we're talking about the fourth important layer of the convolutional neural network, it's connectedness. Here we're just making sure that all of the activation functions are applied correctly by making use of the bias, and generally checking that the entire neural network is connected thoroughly and it's working as expected as well. So as the name suggests, this is a very important layer to verify the understanding of the neural network. So these are the four very, very important layers that you have to know about in this particular order itself. Whenever you're mentioning the working of it, the questions can be like, what is the working of a CNN, or what are the layers that are present as well. So this will develop as both of those questions. Now, when you talk about RNN, as I just mentioned, next question can be, what is an RNN in deep learning? So RNN, as I discussed, it stands for recurrent neural networks, and unlike CNNs, the working here is very different. The use of it is very different because RNNs, or recurrent neural networks, are very, very efficient at working with a lot of string data, textual data, genome data, handwriting data, and much more. So if you have already worked with any basic use cases where you're performing, let's say, handwriting prediction or detection of handwritten letters or whatnot, then there's a good chance that you've made use of an RNN. RNN uses the technique called as backpropagation that we've already discussed for all its training requirements, and it is very, very effective at doing this as well. Just like how CNN is very effective for working with images, it shows similar girth whenever you're working with textual data as well. So this is again a very important aspect in deep learning. Now with this we can come to the 29th question that says, what is a vanishing gradient whenever you make use of recurrent neural networks? A vanishing gradient, to be honest, can be considered as a scenario, because we already saw in the last answer that RNNs make use of backpropagation, right? So if there is backpropagation, then there's the calculation of the gradients at every single step. And whenever we work with backpropagation, whenever we calculate gradients, they tend to get smaller and smaller as the data works backwards from the output layer to the input layer. So since the value becomes extremely smaller towards the end as we approach the input layer, it causes a problem. So this basically means that your model will learn very slowly, and it cannot be efficient. It will underlearn sometimes, and it will cause a lot of problems. So this is a scenario of occurrence where your gradient values are becoming very low, and that scenario is what we call as the vanishing gradient. Now, I hope this is clear. So with this, we can move on to the 30th question, which states, what is exploding gradient descent in deep learning? Just like vanishing gradient, exploding gradients are another issue which work in a very different way, because here is a scenario where we're clumping up all of the gradients. Means what it does is it will create a large number of updates for all of the weights in the model whenever it's training. So your model weights are being updated constantly, more than required, and and we already know the working of gradient descent, right? So it's based on the condition to keep all of these updates small to make sure that your upgrades are controlled, and only then can your gradient descent have some meaningful impact on your deep learning model. So with this, we have to understand that whenever you control these updates that happen to the weights of the model, right, this will have a huge impact, in fact direct impact, on the efficiency of the model as well. So this is another scenario, what we call as the exploding gradient descent, where we have large number of updates that happen to the weights, which make it very, very inefficient at the end of the day too. Now with this, we can move on to the 31st question. So the 31st question states, what is the use of LSTM? LSTM is again a very important type of recurring neural network that we use to perform a variety of operations whenever we work with textual data and string data, as I just mentioned a couple of slides ago. So it stands for long short-term memory, and the working of it is slightly different because it makes use of something called as feedback chains, where it gives the network the ability to perform like another general purpose computing entity as well. So when it comes to that, it is very efficient at working working with a lot of data, especially when we're talking about genome data and genomic sciences. LSTMs are very efficient at working with that as well. So again, just being a type of another RNN, it sort of trickles down to having all of the features and the general working of RNNs too. Now with this, we can come to the 32nd question that states, where are autoencoders used? So we checked out autoencoders before, but then there might be a follow-up question to that stating where they are actually used, right? So you have to understand that autoencoders again have a lot of usage in the real world. So whenever we talk about it, you can have about 10 to 15 uses that, of course, that you might know already. But then it is vital that you at least mention 3 or 4, very popular applications of it as well. So let's say in the real world, if you have a black and white image and you want to have it colored out to what it actually was in its real life, then adding color to black and white images are very important use cases. And if you have any other old images where you have to remove noise, autoencoders are used here too. And then when you talk about dimensionality reduction and feature removal or feature variation as well, autoencoders seem to be very popular. And in fact, more than popular, they're popular for a reason, that is because they're efficient at handling all of these tasks. So make sure you mention all of these real life applications which are very popularly used as well. So with this, we can come to the 33rd question that states, what are the type of autoencoders? So, there's actually 4 types of autoencoders that you have to mention. One is the deep autoencoders, we have convolutional autoencoders, we have sparse autoencoders, and of course, we have the contractive autoencoders as well. So you really don't have to explain when you're asked for the types, but then it might add value if you can just state 1 or 2 sentences about each. But then it is very important that you mention all the 4 types that exist for autoencoders as well. So moving on, we come to the 34th question that states, what is a restricted Boltzmann machine, or an RBM for short? An RBM is actually a graph, if you have to talk about it in general. It's a graphical based model that we make use of in deep learning today, and it does a lot of things and can do a lot of things efficiently as well. So when you have to talk about performing operations such as classifications, or let's say regression, dimensionality reduction, be it collaborative filtering, topic modeling, or all of these operations that need to be performed that require an algorithm to do it, an RBM can do it very effectively in today's world of deep learning, where it can make use of the computational power of today and work with it effectively as well. So an RBM is again a very, very important, I know there's a lot of efficient being used in the case of deep learning, but then of course an RBM is very tricky to work with at the same time, but then the output that it provides is worth the effort. Coming to the 35th question, it states, what are some of the limitations of deep learning? We've been talking about advantages for 34 questions now. So it is very vital that you know what some of the limitations or the disadvantages are. There are not many disadvantages, but then there are a few disadvantages as well. The first one is, whenever you expect very good, very accurate output, you need large amounts of data, and your network has to have the capability to work with large amounts of data effectively as well. So that is one disadvantage. To gathering all the data might not be the case in all the factors. And then when we talk about how complex it is to implement, for example, an RBM is pretty complex for a beginner to work with and to get it working efficiently as well. So in a couple of cases, not just RBMs, RBMs might be easy to you, but then there are many concepts where it can be a little convolutional, it can be a little confusing, and it can be a bit complex to work with as well. So that is one of the disadvantages. And just like any other deep learning concept, your main focus always will be to make sure that your models are very efficient. So you'll be hunting on keeping that loss function down. You'll be hunting on making sure that your goal parameter is being met, and it is being met in a way where your model is very accurate. It is not overfitting a lot, it is not underfitting a lot, and it is performing as it should at its best. So hunting for these can take a lot of time, and it is not as simple as it's put out as well. So in case if you have had first-hand experiences working with deep learning, you will know what I mean with this. Now, we can come to the 26th question that states, what are the varieties of gradient descent that are available, or what are the variants of gradient descent? There are actually 3 very important distinctions whenever we talk about gradient descent. One is the SGD, or the stochastic gradient descent, then we have the BGD, or the batch gradient descent, and then we have the mini batch gradient descent. And whenever the talk is about stochastic gradient descent, the first important thing is that we only make use of one training example, and we calculate gradients based upon that. We update all the parameters based upon this single entity, this single example that we have. But then this is not the case when we talk about batch gradient descent, because once we calculate a gradient for batch descent, as the name suggests, we'll take the entire data set and calculate the gradient for all of the entities that are present in that data set, and then of course we update all the parameters one after the other in every iteration as well. And mini batch is again very similar to batch gradient descent, but then the batches itself are broken down into digestible pieces or small sized chunks, or small sized batches as it's also called, and then work with it just like how if it was a stochastic gradient descent, where we again take a simple training example and we make sure that we calculate gradient, update all the parameters, and perform the same operations for different values across a variety of iteration as well. So these are some of the three important gradient descent, stochastic gradient descent, batch gradient descent, and mini batch gradient descent that you have to mention when you ask this question. So with this, we can check out the next question that states, why is mini batch gradient descent so popular? So why is mini batch so popular, right? So this is again a question that's asked a lot. In fact, it's a very frequent question if you talk about the previous question or a follow up to that as well. So one reason why it is popular is of course because it is very efficient when you directly compare it against stochastic gradient descent. And when we talk about avoiding the concept of local minima, mini batch gradient descent will help, because we'll be approximating all of the gradient values for the entire data set, and this is done because we use a concept called as generalization rather than hunting for specific values every single time by doing this concept where we're finding the flat minima and working with it. So what this does is make sure that we can avoid the local minima, we can approximate the gradient for the entire data set by the process of generalization, and it can be done very easily as well. So it packs a punch without having much effort into it. So that's one advantage of mini batch gradient descent. Now with this, we can check out the 38th question that states, what are deep autoencoders, right? So we checked out regular autoencoders. So what are deep autoencoders? Deep autoencoders are actually an extension of the regular autoencoders that we just checked out before. So here the difference lies where, the first layer is actually responsible for what we call as the first order function of the input. And if you have a second layer, then the second layer will take care of what we call as second ordered functions. Third layer will have a third order function. Fourth layer will have fourth ordered functions, and so on. So it goes on like that. So when we talk about a deep autoencoder, it is basically a combination of making use of two or more symmetrical DBNs that we discussed, right? So DBN is a deep belief network. So here in an autoencoder, we combine two or more of these deep belief networks, where let's say the first 5 layers is considered as the shallow layers, which will take care of the encoding aspect of it, and the last 5 layers, or in fact all of the other layers, can handle the decoding part as well. We checked out that encoding and decoding are two very vital aspects of autoencoders, and this is where deep autoencoders shine, and how they are complementary to the regular autoencoder as well. So with this, we can come to the 39th question that states, why is the leaky ReLu function used in deep learning? So ReLu stands for rectified linear unit. So leaky ReLu is also called as LREL. In case if you asked about LREL, make sure to understand that it is the same as leaky ReLu. So, we use leaky ReLu in a concept, let's say, where we have the input values, and if they, if the input values are all less than 0, right? So what we try to do is we allow the passage of, small sized negative values to the function, where we use it to actually manage the function, work with it, and then, to drive the activation based upon that as well. So whatever neurons require activation, if the values are less than 0, leaky ReLu is very popular there, which will allow the usage of small negative values and drive meaning out of that at the end of the day. So after understanding leaky ReLu, it becomes very vital that you check out some of the examples of supervised learning algorithms. So, this is a machine learning question, but then we've seen this has been asked a lot in deep learning interviews as well. So what are some of the examples of supervised learning algorithms in deep learning is the question. You have to understand that there are 3 main supervised learning algorithms in deep learning. One is ANNs, artificial neural networks, then you have CNN and RNN, convolutional neural networks, and recurrent neural networks respectively. So you have to mention the 3 types or the 3 main supervised learning algorithms usages in the field of deep learning as well, and these will cover all of the subfields that come under them. CNN has a lot under it as well. RNN has a lot of types, as we just checked out in the previous set of questions, but then mentioning these 3 should be more than sufficient. Now, There can be a follow-up question to this stating, okay, what about unsupervised learning algorithms? Can you state examples of that in deep learning? Well, yes, there are three very main important unsupervised learning algorithms in deep learning. We've checked all of these out. One is the autoencoders, then we have the Boltzmann machine, and of course we have something called as self-organizing maps as well. So these three form to be very, very important unsupervised learning algorithms that find a lot of usage in the real world when we make use of deep learning and its concept too. Coming to the 42nd question, it states, can we initialize the weights of a network to start from 0? Can the weight be 0? The answer is very tricky. You might be, leaning to say no, but then understand that the answer is yes. It is actually possible to start with 0 initialization. But then, of course, it is not recommended to use, because setting it up to 0 will make sure that your neurons will be giving the same output and the same descent and the same gradients whenever we go on to make use of back propagation. So the learning is almost next to 0 or next to nothing here. What this means is that your network cannot learn at all if we start with 0, because there is no asymmetry, right? So each of the neurons have to be unique from each other, and they have to do a unique task that is assigned to them. So if everything is set to 0, then when we work with back propagation, there is no way to tell apart from one neuron to the other. So the learning rate is 0, as I just mentioned, and it really doesn't work. But then yes, it is of course possible where you can have 0 initialization done to the weights before working with the network as well. So after understanding this, it becomes very vital that you understand something called as same padding and valid padding in CNN. So you remember CNN is used for image classification as well, and padding is done as a part of working with images. So whenever we perform iterations, with every iteration the images are being shrunken in size. To make sure that they're not shrunken beyond usage, we do padding, where we apply more dimension to the existing matrix, right? So there are two types of it. One is valid padding, and we have same padding. Valid padding is where it is used where it is where there is no requirement for padding actually. So the output matrix will have the dimension n minus f plus 1 multiplied with n minus f plus 1, which happens after the convolutional state. And with case of same padding, padding elements are common padding elements, in fact, are added across all of the output matrix as well. So same padding is a situation where we try to match the dimension of the input matrix as well, but then valid padding might not be matched because it can have its dimension on its own, which is calculated by the formula given there as well. So same padding will try to match all of the elements after padding to make sure that your output matrix will have the same dimension as the input matrix. So that is the basic difference that lies between valid padding and same padding. Now, it is very important that you might be asked this question, so make sure to concentrate on this as well. So what are some of the applications of transfer learning in the case of deep learning? Transfer learning is a very popular scenario where we take a large model, we train it with a huge data set, yes, of course, and then we make sure to use this model, which has learnt on very complex data, large amounts of data, to work on simpler data set. So what this does is its efficiency is boosted to a very high extent because it has actually trained on complex data, but it is now working on simple data. So this way it is very efficient, it is very accurate, and in fact transfer learning is being implemented in our daily lives very well as well. But then if you have to talk about the complex use cases of it, we have BERT, we have ResNet, we have GPT-2, we have VGG16, and many other popular examples of where transfer learning are made use of and how efficient and effective they are as well. But then understand the basic working of it. So you train your model on something very complex, but then you actually show simpler data to it at the end of the day where it can work with it effectively and be more efficient too. It's as simple as that. Now with this we can check out the 45th question that states how is the transformer architecture better than recurrent neural networks in deep learning? So, whenever we make use of something called as sequential programming, there are two important things you have to be concerned with. One is how much of processing power you're making use of at every single point of time. And so what is the difficulty that you're facing whenever you have to work with parallel execution, right? So sequential processing will raise these two red flags. And what this does is this actually gave away these two concerns with the primary reasons why we have something called as a transformer architecture now. So in a transformer architecture, we have something called as the attention mechanism. The attention mechanism will take all of the dependencies that are available and it will map in between each of the sentences whenever things have to be processed as well. So when we talk about concepts such as NLP, right, natural language processing. Here, since the data is mostly sequential, it'll of course bring up the two concerns as mentioned above. But then by making use of these attention mechanism, by mapping all of the dependencies, by making sure your model can recognize these entities faster and map it across to a dictionary faster, let's say, then transformer architecture is very effective, as you can think about it. So with this, we can check out the 46th question that says, what are the steps that are involved in working with an LSTM network, long short-term networks, as we discussed in a couple of questions before. So, whenever you're working with LSTM, there is three important steps that you have to think about. The first step is concerned with the network actually picking up all of the information, where it has to remember certain things, it has to identify what it has to not remember and what it has to process as well. So that is the first step, where your network has the capability to know what it has to remember and what it has to forget. And then when we come to step number two is where we actually update all of the cell state values, but then updating all of these will depend directly on the outputs of the step one, because depending on what information needs to be remembered or not, the cell state values are updated based on that. The third step, in fact, also depends on step number two, because here what we're trying to do is getting the network to calculate and analyze what is the current state, and which part of the current state should in fact make it to the output and which should not as well. So the most important step is step 3, but then without step 1 and step 2, it is very difficult to directly move on to 3, because you will need what is vital and what is not. Then you have to update the cell state values based on that, and lastly you have to make sure your network analyzes and calculates which part of the current state should make it to the output and which part should not as well. So these are the 3 steps that are very vital in the working of an LSTM network. Now we can come to the 47th question that states, what are the elements in TensorFlow that are programmable? So what are the programmable elements whenever you're working with TensorFlow as a deep learning framework? So the answer is very simple. It is very straightforward. In TensorFlow, all the users have the ability to program 3 main elements. One are the constants, one are variables, and one are placeholder entities. So these 3 entities are very important that you state out explicitly, because these are the entities that you can program explicitly, program manually, and work with them, depending on whatever model it is that you're working with as well. So after understanding this, we have to check out one more small concept called as bagging and boosting in deep learning. So the question can be, what is the meaning of bagging and what is the meaning of boosting in deep learning? So what happens in bagging is that, we actually take a data set, we split the data set, and we randomly shuffle around, move the data into multiple batches, or in fact we call it as bags, since the term bagging is used, and we use it to train the model as well. And then boosting is a different scenario where we take incorrect data points and we force a model to actually produce a wrong output. We give it a wrong input, we make sure it gives the wrong output. So this way the model has the capability to understand that, okay, this is wrong, and then it can retrain itself and increase accuracy as well. So this is a negative way of teaching the model, but then it works very, very well. If your model can understand what is wrong, that means that it knows what is right. So this way, making use of bagging, where we're splitting the data set, or making use of boosting, where we are giving it the wrong input and the wrong output derived from it to teach it better. Both of these are helping very effectively in the case of working with deep learning as well. Now with this, we can come to the 49th question that states, what are GANs or generative adversarial networks as well? So GANs are again very, very widely used. They are used to achieve this concept called as generative modeling in deep learning. What it is that it is an unsupervised task that basically is involved in a lot of pattern detection and pattern hunting in the data. So whenever we have an input data, we try to see if we can find out any patterns in it and make sense of it and convert it into a meaningful output. So GANs are very, very useful for this. So the generative part of it comes from the generator, where it is used to generate more than one example at a time, while we have another entity called as the discriminator. A discriminator will classify the examples which get generated by the generator. So the 2 entities, generator and discriminator, and it would add some value to your candidature if you actually mention these explicitly to the interviewer as well. So GANs are again they're very widely used, because whenever you think about it, everything is pattern detection in today's world, right? So GANs have a lot of implementation and a lot of requirement by us as well. Now with this, we come to the last question that states, have you earned any sort of certification to improve your learning and implementation process? Well, the answer to this is very important, because as you might already know, a certification program can give you a lot of advantages. Structured method of learning, a lot of use cases, real time projects, expert guidance, live classes, and to you this is fine. But then to the interviewer, what they are trying to understand from your certification program is, with the certification program, you are trying to show that you want to exceed in your career, that you want to build something, that you want to advance in your career. That is the first important point. The second important point is that, let's say if you're a fresher, if you learned it all on your own without having to learn it in college or something, that shows grit, that shows aspiration. And if you're a person who's moved from another programming language to come into the field of deep learning as well, that again shows very strong aspiration, that you are willing to put some time and effort, and that you've already put time, effort and money into learning all of these as well. And at the end of the day, that adds up to a concept where you're proving yourself to the interviewer that you are effective at what you do and you want to do this. So one very important thing that you have to know whenever you're talking about certification programs, right? So yes, you can list all the certification programs that you have had, but then what will add the most value is to tell the interviewer what you learned and how you used your learning to implement something new. See, because not just certification, any IT concept in the world, right? So we're trying to solve a complex problem using a simpler thing. So we're trying to make the complex problem very simple. So how have you taken a complex problem, how have you worked on it, and how have you simplified it by making use of your certification program is very important to the interviewer, and that is what you should talk about. Explain what you learned from it, explain how you learned and what you took away as well. And here is a small bonus for you guys. Apart from this, what would add a little more value is to make sure that you mention that that you're planning to use your learning in this particular way for that particular company that you're applying for, right? So you would have learned a lot of things. If you put it out in a way where you're telling the interviewer that, hey, I learned all of these and I think I can use it this way to help your company, that will impress the interviewer as well. So that is one very important way on how certifications will help you rapidly increase your career's dimensionality, basically. Well, with that, you have reached the end of this top deep learning interview questions. I take this opportunity to wish you all the best for all the interviews ahead. So you make sure to use this guide to understand how you can approach the questions effectively and how you can answer them precisely and with as much content and quality as possible. So I'll see you on the next one.